In Windows Forms, controls have fixed coordinates. Every control has a location property that has X and Y coordinates, and those represent the upper left corner of the control relative to the upper left corner of the container. So basically, when you put a control in a form, it stays in the position you put it in. Now you have some flexibility. For example, you could dock the OK and the Cancel buttons to the lower right of the window. That way, at runtime, if the user resizes the form, the OK and Cancel buttons stay where they are. You might anchor a list box to the left-hand side of the form. Or you could use the Flow Layout panel control to arrange controls in a flow layout. There was also the Table Layout panel. You could arrange controls in a table format. So with docking and anchoring in those two panel controls, you had a little bit more flexibility, a little bit more control over where things wound up at runtime. But in essence, you put a control in a Windows form, and then at runtime it stays where you put it. So in web forms, controls by default are anchored relative to the upper left of the page. Controls flow left to right, top to bottom, and their relative position is fixed. Now you can specify absolute positioning if you wanted to, but most people just stick to the default. And because controls are anchored, if you resize the browser window, it doesn't change the relative position of the controls. So I mention these because this is what you're used to, and layout in XAML is different. XAML uses a flow-based layout, although there is some support for coordinate-based layout, but in general it's a flow layout. And content's organized into containers. Each window or page can have one element, so that element's going to be a container, and then into that container you add elements. And you can add containers into containers. So there's basically a containership model. So what are the benefits of the XAML layout system? Well, you get resolution and size independent interfaces. And that means that the layout adjusts automatically if the screen resolution or the size of the window or the content changes. So no longer do you just put controls on a window and they basically stay in the same absolute or relative position. As the resolution changes, as the user resizes the window, the XAML layout system will automatically resize and reposition your controls. This is a big benefit. It also makes it complicated until you understand it. So XAML layout is recursive, and the runtime makes two passes before it actually draws any elements. In the measure pass, it basically asks each element, what size would you like to be? So if you have a button, it's going to look at the text in the button and say, what size do you need to be to display the text in the button? In the arrange pass, it determines what position each element should be in. And this layout can occur many times. If you add or remove an element at runtime, or you resize an element, resize the screen, resize the page or a window, then the layout system will once again make the same two passes, the measure pass and the arrange pass. So you do need to be aware of this, because if you're constantly resizing the window or changing the resolution, then the layout system has to query the elements again and then arrange them. In Windows Forms and Web Forms, controls have a fixed size. If you put a button on a Windows form and then change the size of the window, the button doesn't change its size, but in XAML it does. So how does the XAML layout system determine what size elements should be? Well, all elements are surrounded by a bounding box, and that represents the space that's going to be allotted to the element. And then the actual size at runtime is determined by calculating a number of things. What's the available screen space? What's the size of any constraints, such as the size of the container the element's in? What are the values of any layout-specific properties like margin and padding? And we're going to see those in a second. And then what's the behavior of the parent panel? And then therefore the size of the element can grow or shrink. So here's a simple example of a text block and a button. And then in the yellow, that shows the bounding box for the text block. That is the available space for that text block in this window. Alignment tells you how child elements should be positioned within the allocated layout space in the parent element. So for example, if you have a stack panel and inside that stack panel you have buttons, the alignment tells you how the buttons should be positioned given the amount of space available within the stack panel. And you can control this by setting the horizontal alignment or vertical alignment properties of elements. Horizontal alignment can be left, center, right, stretch. Vertical alignment can be top, center, bottom, stretch. So here's an example of using horizontal alignment. Button 1 has its horizontal alignment set to the left, button 2 to the right, button 3 to the center, and button 4 is stretch. So button 1 is essentially anchored to the left of the parent, button 2 is anchored to the right, button 3 is anchored in the middle, and then button 4 will resize itself to fill all of the available space. Here are 4 examples of the vertical alignment. Button 1's on the top, button 2 is on the bottom, button 3 is in the center, and button 4 stretches, so it will stretch vertically to take up all of the available space. The margin and padding properties turn out to be very important as you're laying out your user interface, because they're very important in terms of getting controls to be where you want them to be. The margin describes the distance between an element and its child or peers. So the distance between a stack panel and a button in it, or the distance between 2 buttons within a stack panel. And the margin property is made up of left, top, right, and bottom. And there are 2 ways you can specify these, individually or uniformly. So in this first example, we're saying, on this particular control, I don't need any additional pixels on the left. I want 10 pixels on the top, none on the right, and 10 on the bottom. Now if you just want 5 all the way around, you could say margin equals 5, 5, 5, 5, or you can just say margin equals 5. The definition of the padding property says that it enlarges a child element by a specified thickness, but what it basically does is it adds space between an element and its child element. So it's similar to margin, although it's not available for all elements. So a good use of it would be on a border. So you have a panel, and then around that panel you want to have a border, and you want space between the border and the panel. You'd set the padding property of the border. So here's an example of alignment, margin, and padding. So this is what this window would look like at runtime, and here are the properties that get it this way. So you'll notice the black box around is a border, and its padding is set to 15. So then inside that is some panel. Could be a stack panel, could be a grid. Button 1 has its horizontal alignment set to left and its margin set to 20. So the button is anchored on the left, but there's 20 pixels between it and the container on all sides. Button 2 is horizontally aligned to the right and has a margin of 10. And then button 3 has no margin, so it butts right up against the panel, and its horizontal alignment is set to stretch, so it widens to take up the entire width. So those are the basics of the XAML layout system. The next thing we want to do is look at the various container elements and see how we can arrange controls within them. There are 5 primary elements you can use as containers. Containers contain elements. Remember that each window or page has one container, so that element's going to be a container. And then inside that container, you'll have elements such as text blocks and text boxes and buttons, etc. There are 5 primary containers that you can use in your XAML apps. The stack panel stacks elements horizontally or vertically. The wrap panel places elements in rows or columns that wrap as needed, so as you resize the window, you get additional or fewer rows and columns. The dock panel aligns elements along one of the edges, the top, the bottom, the left, or the right. The grid places elements in rows and columns, and then the canvas places elements according to coordinates. So if you use the canvas, then the elements stay where you put them at runtime, even if the window resizes. If you use any of the other 4 containers, then your elements will resize and be repositioned. The stack panel stacks its child elements either horizontally or vertically. The default is vertically. If you want them horizontally, then you can set the orientation property. And you can control where elements are positioned by setting either their horizontal alignment or vertical alignment properties. And by default, there's no spacing between elements, but you can control the spacing by setting the margin and padding properties. So the runtime determines the size of each element. And elements are always going to be at least their minimum size. And that's determined primarily by the content. So in other words, if you have an OK button, it's always going to be at least wide enough to display the O and the K. If you want your buttons to be at least a certain size, then you can use the min width and the min height properties. Elements will always be less than their maximum size. If you think about it, the maximum size of an element is the size of the container it's in, so it can't be larger than that. And then if possible, elements will be enlarged to fit their content. But if the width they need exceeds the width of the container, they'll be cut off. So for example, you have a button that says, click here to see more information on these wonderful products. If the stack panel that the element's in isn't wide enough to display that, then the button's going to be cut off. And elements will stretch to fill the container if the horizontal alignment or vertical alignment properties are set to stretch, and that is the default. So let's go see some examples of putting elements inside a stack panel. I have the layout examples application running. Let's go look at some examples of using the stack panel. So here's our first example. Let me just get rid of these two windows. Here's our first example of a stack panel. Now the stack panel stacks the elements in it vertically. So in this stack panel, I have a text block and 4 buttons. And I've just kept this really simple, only setting the text property of the text block and the content property of the 4 buttons. And it stacks them from top to bottom. So text block 1 is jammed up against the top and the left, and then button 1, 2, 3, and 4 are right under that, no spacing in between them, and buttons 1, 2, 3, and 4, as well as the text block, are resized to fill all of the available space. So what that means is that if I resize this window, the buttons and the text block will resize horizontally to fill up the entire window and actually fill up the entire stack panel. Now the text block doesn't look like it's resizing, but it actually is. The only thing you see is the text. Now what this means, well, there is a limit to how narrow I can make this, but there is no limit to how tall I can make this. So I can actually hide all the buttons and most of the text block. There, actually I can hide everything. Now I do have some control over this. That may not be the behavior I want. So if I stop this application and I come in here and instead of using height and width, I use minimum height and minimum width, then I can have some control over that. So let me just change this, and I need to comment that. There we go. And now I'm saying that the minimum height of the window is 150 and the minimum width of the window is 300. And now when I run this, now I come into Stack Panel Examples. Here's the first example. I cannot make this window smaller than 150 tall and 300 wide. So if you want to control whether or not the users can size a window so small that it hides the controls, you can use the min width and the min height. Okay, let's look at our next example, which is horizontal orientation. By default, the stack panel stacks its elements from top to bottom. You can instruct it to stack them from left to right, and here I did that by setting the orientation equal to horizontal. So text block 1 is jammed up against the left, and then button 1, 2, 3, and 4 in order. And again, they stretch to fill all of the available space, not the space horizontally, but they stretch to fill the space vertically. Okay, let's look at our third example. I can control how much they stretch or not by setting the horizontal alignment property. So here what I've done is set the horizontal alignment of button 1 to the left, button 2 to the right, button 3 to the center. So button 1 will now essentially be anchored to the left of the window, button 2 to the right, and button 3 in the center. Button 4 has its horizontal alignment set to stretch, which is the default, so I don't really need to type that. And now as I resize the window, button 1 stays to the left, 2 stays to the right, 3 stays in the center, and button 4 resizes to fill. There's also a vertical alignment property. Let's take a look at that. And here I'm stacking the elements horizontally, so I can control their alignment by using vertical alignment. Button 1 has its vertical alignment set to top, button 2 set to bottom, and button 3 set to center, and button 4 again has its vertical alignment set to stretch. So as I resize the window vertically, button 1 stays at the top, 2 stays at the bottom, 3 stays in the center, 4 will always be as tall as the window. In our next example, we want to look at setting the margin. Now let's get that first example back. Notice here that by default, there's no space in between the elements, and there's no space in between the elements and the window. Text block 1 is in the upper left of the window. There's no space here on the left-hand side of these buttons or on the right, and there's no space in between them. To get space in between elements, I can use the margin property. So here I've set the margin of the stack panel to 5, which says that on the left, top, right, and bottom of the stack panel, I want there to be a 5-inch space. And then text block 1, the text block has its margin set to 10. So again, on the left, the top, the right, and the bottom, I want 10 pixels. So that says that between the left of the text block and the left of the window, there's 15 pixels. 5 from the stack panel and 10 from the margin of the text block. Between the top of the text block and the top of the stack panel, again, 15 pixels. Text box 1 has its margin property set to 10 on the left, top, right, and bottom. So between the left of the text box and the left of the window, 15 pixels. Again, 5 from the stack panel, 5 from the text box. Between the top of text box 1 and the bottom of the text block, 20 pixels. 10 from the text block, and then 10 from the text box. Button 3 has its margin property set to 10 on the left, 25 on the top, 25 on the right, and 10 on the bottom. Now in this example, 10 on the left is a bit redundant because there's nothing to the left of it. I could have left that at 0. I could set it at 10. I could really set it at almost anything. As long as what I set it to is less than this distance, then the button will stay where it is. The important one here is the 25 on the right. So I've got 5 pixels from the stack panel and 25 from the button. So this button is 30 pixels in from the right, and it is 35 pixels below the bottom of the text box, because the text box here has a margin of 10, and then I have 25 as the top margin of the button. And then in between button 3 and 4 is 20 pixels. 10, which is the bottom margin of button 3, and then plus 10 more, which is the top margin of button 4. And now as I resize this, notice that button 3 and button 4 stay 35 pixels to the right. Oops, where'd it go? There it is. Buttons 3 and 4 stay 35 pixels to the right of the edge of the stack panel. The text boxes resize to fill up the entire window, but there's always 15 pixels here and 15 pixels here. So the margin property winds up being very useful and very important in terms of arranging elements. So I now have the basic layout of this window staying the same even as it resizes because I'm using the margins. And button 3 and button 4 no longer resize to fill up the entire window because I have the horizontal alignment set to right, and then I fix them in relation to the edge of the window by setting the margin. In our next example, we're going to take a look at padding. So here I have a border. The border brush is set to black, the thickness is 3, and then I have a padding of 5. And that says that on each inside edge of the border I want 5 pixels. And then I have the same controls I had before. So now from the text block to the top is 5 pixels from the border, 5 pixels from the stack panel, and the same thing on the left. So the padding basically adds space between the border and the elements it contains. Let's take a look at sizing. In this form, the user enters their favorite foods, and then I have OK and cancel buttons. Now in terms of position, these buttons are where I want them to be, horizontally aligned on the right, margins set, but they're not the same size. And that's because the runtime will size elements to be at least their minimum width. The runtime queries the first button and says, how wide does this need to be to display the letters O and K? And then it makes that button that size. Looks at the second button and says, how wide does it need to be to display the word cancel? And it makes it that size. Now in the previous example, button 3 and button 4 are the same width, not because there's some magic size to buttons, but because the width of the text in each of them is the same. When the width of the text differs, as it does here, then the buttons will be a different size. I can control this by using the min width property. So now I've set the min width property of the OK and cancel buttons to 50. And because that's wider than they need to be, both buttons will be 50 wide. Now how did I decide on 50? I might eventually decide that 50 is the width of buttons, but here I think I set it to 35. That was a little narrow. I set it to 75. That was a little too wide, and I chose 50 as a nice compromise. So what you've seen in this demo is how to use the stack panel, and also how to use the various properties of elements to get better control over how things lay out at runtime.